Hello everyone. Today we're going to look at how we can figure out the pH of a solution that contains an acid and a base. So previously we talked about how to find the pH of a solution that is acidic. We could simply, if it was a strong acid, we could use pH equals negative log of the acid concentration. And if it was a weak acid, we would have to do a little bit more work. We'd have to use Ka, maybe an ice table, and solve for the hydronium concentration. Okay, we learned how to find the pH if it was a base. We could either use POH, which is negative log of the base concentration, or we could use hydronium times hydroxide equals 10 to the minus 14. Right? And as long as we knew the hydroxide concentration, we could solve for the H3O plus concentration. But what if we have an acid and a base that have reacted? A lot of times when we are dealing with acid-base chemistry, we are mixing acids and bases to react them. The idea here is that when we have something that's acidic, it's forming these hydronium ions in solution. When they meet with a hydroxide ion, they're going to react in a neutralization reaction to form two neutral water molecules. Okay, as long as we are able to react all of the hydronium and all of the hydroxide, we should end up with a neutral solution. So let's look at this. Okay, key idea is that one hydronium neutralizes one hydroxide. Some acids are able to produce more than one hydronium per acid, and some bases form more than one hydroxide. But one hydronium neutralizes one hydroxide. Okay, so let's look at a practice problem. Okay, this tells me 40 milliliters of 0.5 molar HCl, which is a strong acid, reacts with 60 milliliters of 0.3 molar NaOH, a strong base. Is the resulting solution acidic or basic? Okay, so again, looking at our key idea here, one hydronium neutralizes one hydroxide, and we want to just see which one do we end up with in the end after we've neutralized all of either our hydronium or hydroxide. Okay, so I like to start all chemistry problems that involve reactions with a balanced equation. This is going to be HCl, NaOH, standard hydroxide with acid to form water, and a salt. Make sure that it is balanced, which it is, 1-to-1 ratio. Okay, next we want to determine the mole amounts of each reactant. Okay, so we're going to use moles equals concentration times volume. In this case, the acid is 40 milliliters. I'm going to convert that to liters times 0.5 moles per liter, or molar. This comes out to be 0.020 moles of HCl. I'm going to do the same thing for my base. 0.06 liters of base, 0.3 moles per liter. Okay, and this comes out to be 0.18 moles of NaOH. Okay, so keep those numbers handy. Our last step is we are going to use a BCA table to find out what is left over. Essentially, this is a limiting reagent problem. We want to find out if NaOH or HCl is limiting and how much of the excess is left over. Okay, so if you understand limiting reagent problems, it shouldn't be very hard to tell which of these two will be used up first because they do react in a 1-to-1 ratio. So whichever one you have more of, well, that one's in excess. So let's see, right? I can tell HCl 0.02 moles, that's greater than 0.018 moles. Okay, HCl is in excess. So let's look at this in a BCA table. I like to write it right underneath our balanced equation. I'm not going to do anything with the products because they don't affect the pH. They're not acids or bases. I have 0.020 moles of HCl, 0.018 moles of NaOH. Remember, we put moles into a BCA table. That's why the second step required us to find the mole amounts of each reactant. Okay. The change row, I will use up all of my NaOH, and I will use, they react in a 1-to-1 ratio, so I'll use an equal amount of HCl. This leaves us with 0.002 moles of HCl left over. Okay, so this resulting solution has excess acid, meaning it is going to be acidic. 0.002 moles. Okay, suppose that the next part of the question were to ask you, what is the pH of this solution? Well, we could find that too, because I know that I have 0.002 moles of HCl in what volume of concentration, or what volume of solution? I start with 40 mils of acid and I mix it with 60 mils of base. So my total is going to be 40 mils plus 60 mils, or 100 mils of solution. Okay, I could find the concentration of that. C is moles over volume, 0.002 moles HCl over 100 milliliters, or 0.1 liters. This comes out to be 0.02 molar HCl. Okay, so if you remember how we would find the pH of this, pH is the negative log of 0.02. Okay, so this is going to be a pretty low pH. After we mix these two together, we still are left with a very acidic solution. Negative log 0.02 comes out to be 1.7. All right. So this is how we would do a problem. Remember, this problem wasn't actually asking for a pH, it was just asking is the resulting solution acidic or basic. If you understand how to do it, you might not even need a BCA table. We can simply recognize that we have 0.02 moles of HCl, 0.018 moles of NaOH. Knowing that these react in a 1-to-1 ratio, I can see that this is an excess, right? And this is our limiting reagent. Okay. And again, with some practice, you could just simply subtract these from each other and figure out how much HCl is left over, potentially without a BCA table, but I would suggest using the BCA table when you're just starting these types of problems. Okay. These are pretty tricky. But if you follow these steps, always start with the balanced equation and always convert to moles before you jump into the BCA table. If you follow the steps, should work out for you. Please let me know if you have any questions via email or Google Classroom. All right, have a good one.